Try, adapt, learn. In this video, we will try to remove the cylinder head and chase the threads on the head studs on our Ford 9N tractor project. If you haven't already subscribed, subscribe now for more videos including DIY, maintenance, and projects. At this point in the project, the water pump was previously removed due to coolant leaking from the shaft. Videos with work done including the removal of the hood will be linked in the description. I then decided to also remove the cylinder head. The fasteners holding down the cylinder head are 6-sided hex nuts. These fasteners were removed with an 11/16-inch socket. The first fasteners removed were also holding the wire harness. The wire harness was then moved to the side. Using the hardware gauge, we can see that the fasteners for the cylinder head have a thread size of 7/16-20 fine thread. I used a die matching the thread size to chase the threads. I chose to start this process immediately after the fasteners were removed while the cylinder head was still installed. The mount for the throttle control shaft was removed. Chasing the threads would help restore them to their original shape. I wouldn't doubt if this is the first time that this process has been done in 80 years. It would have taken much less time just to remove the fasteners than put them on again. Threads in good condition would also help when removing the fasteners in the future as well. The ignition coil mounting hardware was removed. Immediately, this would help with the removal of the cylinder head. Chasing the threads would loosen the corrosion and debris which the cylinder head could be hung up on during removal. As with other videos related to the tractor project, this is not a how-to but more a how I did it. That being said, while using the die on the threads, the proper procedure would include rotating the die back and forth in addition to lubricating the die with oil. I chose to use the die dry so I could brush or blow off the debris. Just keep in mind that doing it this way is not proper and it could risk the threads and the tool. As expected, the fasteners were a little bit tight from all the paint and rust. Although some of the fasteners and studs were damaged on the top, they were able to come off without further damage. If you look closely at the base of the thread which is in the top of the cylinder head, you'll see some of the debris that was removed in this process. Along with the debris from the threads, you can also see the layers of paint built up around some of the base at the top of the cylinder head. And again, although these debris were from the threads only, you can imagine how much rust and dirt would be around if the head itself wasn't scraped and painted before this process. Although this seems to go by quickly, I chose to speed up the video because with many studs and threads, the repetitious process was lengthy. On the engine, there were 18 studs in total. As seen, the threads were chased multiple times on each stud. A wire brush was also used to remove excess debris that were also cleaned off the threads. Some of the fasteners were taken off with hand tools and others with an impact wrench. The most challenging task related to chasing the threads was to start the die off. The die needed to be level so that it would chase the existing thread and not strip or cross-thread it. For most of the studs, it took multiple tries to get this process started. With 18 studs in total, I edited out the false starts to help save time on this video. The fasteners holding the oil filter housing mount were next to be removed. The head size for these fasteners are 9/16. Because the wrench did not initially fit, some of the paint was scraped away. The thread size for the oil filter housing mount measured 3/8-16 coarse. Next, the spark plugs were removed with a 13/16 spark plug socket. Once the spark plugs were removed, a vacuum was used to clean off the excess debris before they would fall into the spark plug hole. I thought it would also be a good idea to remove the cylinder head. Like chasing the threads, the removal of the cylinder head has been sped up. In the very beginning, I started to use a soft hammer, but I knew that wasn't going to be enough to loosen the head. I also used a piece of wood with a hammer to help loosen the cylinder head. Please consider it really took a while as I used multiple firm hits from the hammer. I preferred this method over striking too strong to help to prevent damage to the parts. As seen, I also moved around the head while striking it to loosen it in multiple locations. As you can see, the process of hammering and pulling on the head was repeated multiple times and in multiple locations. As mentioned, removing the head would allow for replacing of the cylinder head gasket. I had no idea when the last time this gasket was replaced. So once again, this would help to reduce the chances of a coolant leak. It would also give another fresh start date related to the maintenance log for the cooling system. Removing the cylinder head would also allow viewing inside the cylinders to see a glimpse of the condition of the engine. As seen inside the cylinder head, there are excessive carbon deposits. This carbon buildup is likely due to a rich condition. When air and fuel is mixed in the engine, the ratio is known as air-fuel ratio. A rich fuel condition means that there is excess fuel in the ratio. In contrast, a lean air-fuel condition means that there is an excess of air in the ratio. The engine on this Ford 9N tractor is a Ford 4-cylinder flathead or L-head. With the cylinder head removed, the gasket could be replaced in order to avoid issues with coolant leaks. Once the cylinder head was removed, the remainder of the threads were exposed. At this time, it was decided to also chase the remainder of the threads. There was excess carbon on the top of the head gasket. I chose to tape over this, the valves, and the cylinders. The tape would hopefully help to catch some of the debris falling off the remainder of the threads. Along with the immediate tasks like replacing the head gasket, this was more an investment for future maintenance. As a side note, we will briefly introduce thread measurement. As mentioned, the studs from the engine block are threaded to hold down the cylinder head with fasteners. The thread on the fasteners measured 7/16-20 fine thread on the bolt gauge. This thread is not metric size, so it uses fractions of an inch rather than millimeters and is measured with the Unified Thread Standard. The 7/16 inches is the major diameter of the thread. The major diameter is a straight measurement of the longest distance from one end of the thread to the other. The pitch of the thread is the distance between the threads. With the Unified Thread Standard, the -20 means that the pitch would be measured as 20 threads per inch. Back to this initial project. Consistent with the start of the threads, I repeated the process several times to clean off the threads. Since the top part of the threads were already chased, it was easy to start the die. Also, since they were already started, I used the box end of a 1-inch wrench and a 1-inch socket on the die to chase the remainder of the threads. Due to the contrast of the blue tape, you can see some of the debris that were cleaned off of the threads. It took a little bit more time, but it was worth it when spinning the new hardware on the threads. I figured that it is likely that I will be removing the cylinder head again. Although it was a little bit time consuming, hopefully the effort now would help in removing the cylinder head in the future later. Now that the threads were chased, cleaned, and the head was removed, the tape was removed to reveal the condition inside the cylinders. Again, excess carbon deposits can be seen. We'll take a closer look at these cylinders and the carbon in another video. As I make new videos, I want to share them with you, so subscribe now. Also comment, like, and check out some of the other content on our channel.